What's up, everyone? In this video, I'm going to be going over the Chapter 6 review for the AP Stats test tomorrow. All right, so as you can see on your screen, these are the 7 topics that are going to be on the test. So in our first one, we have mean and standard deviation of a probability distribution. So the mean, it's basically the sum of all x's and p's. And so x is your values and p is your probability. And then for standard deviation, you're gonna be taking the square roots of the sums of the probability times the value minus the mean squared. So I know this is kind of confusing right now, but once we go through this example, this is gonna be very easy to understand. In the table on the top right, our x values are 5, 10, and 25, and our probabilities are 0.1, 0.4, and 0.5 respectively. And so the way to find mean is that you wanna see which one is paired, and you wanna multiply those. So like I did here, I did 5 times 0.1 plus 10 times 0.4 plus 25 plus times 0.5. And that together gives you your mean, which is 14.5. And then we can do our standard deviation. And this is what I mean by that formula above. So our probability, we get our probability from the table. So 0.1, 0.4, and 0.5. We put those out of the parentheses. And then within the parentheses, we put our x values, 5, 10, and 25. And then the second number within that parentheses is the mean, which we found in the previous problem. So altogether, it's going to be the square root of 0.1 times 5 minus 14.5 squared, and all the other ones. And when you're doing this, make sure you square it. We are then taking the square root, which makes it the standard deviation. So once you compute that, you get 8.5 standard deviation. This is mean and standard deviation for our probability distribution. There are other types of distribution that we will get into later. So this is the overall basis for this. All right. And then this side, I'm putting 3 topics into one. I'm putting combining random discrete variables, transforming variables, and combining random continuous variables. So discrete and continuous variables, those are going to be similar in this case, because discrete is something that you can count and continuous is something that you measure. These are all the rules for each type of thing. So for mean, these are 4 transformations for things I've done. So the mean of A and B is equal to the mean of A plus the mean of B. Question, it says the mean of one thing is 10, the mean of other thing is 5. And if I ask you for the overall mean, you just have to add them, which would be 15 in this case. If I subtract them, it would be the same thing. So 10 minus 5 would be 5. If you have the mean of something and it asks you to transform something along a number line or something, you're just adding that much to the mean. So if the mean was 7, and our B in this case was 4, the overall thing would be 11. Multiplying something. So let's say your mean is 7 and they want you to transform it twice as much. You just have to multiply it by 2. So in this case, it would be 14. The variance. Variance A plus B is equal to the variance of A plus the variance of B. So if we had 4 and 9, the variance would be 13. For subtracting, this is where one of them, this is a tricky one, or something you have to watch out for. So variance of A minus B is equal to the variance of A plus variance of B. So you do not subtract variance, you have to add them. Variance of A plus B, so this is another transformation. But the thing is, variance does not get affected by adding or subtracting. So you just keep the variance as it is. So if the variance was 4 and the B was 7, it would just remain as 4. When multiplying, if your variance is 2 times A, you have to square both things. So it's going to be variance of A times 4, because 2 squared is 4. Standard deviation of A plus B is equal to the square root of variance A plus variance B. So anytime you're combining discrete or continuous variables, you have to use the square root, variance, and add them. This is similar to that of variance, you have to add them. For both occasions, adding and subtracting, you have to add them under the radicand. Standard deviation does not get affected by adding or subtracting constant. So it remains the same. Multiplying, just like variance, but instead you're not squaring it, you're just multiplying it by that constant. Binomial probability. So the 4 conditions for a binomial distribution is number 1, there's a set or fixed number of trials. Number 2, there's 2 outcomes. 3, independent events. And 4, there's the same probability of success for all of the trials. So the formula for a binomial distribution is this. Yeah. And then if you want to find the mean, it's n times p, and the standard deviation is the square root of n times p times 1 minus p. All right, so let's do an example. So let's say Miss Collier is at the free throw line during a basketball practice. She makes her free throws 70% of the time. Suppose she shoots 80 times during the practice. If this is a binomial in the first place. And so If you look at our 4 conditions, is there a fixed number of trials? Yes, it's 80. Is there 2 outcomes? Yes, it's either miss or make. Are there independent events? Yes, because one shot does not affect the next shot. And is there the same probability of success? Yes, 70%. Based off those conditions, we know this is a binomial. And so we can make x equal the number of makes during practice. So let's say, what is the probability that Miss Carr makes exactly 65 shots? So you want to do p x equals 65, the equals, and then everything else. So the top number is your total n, your total sample size. And the bottom number is your x value, the thing you're trying to find. And so in the first parenthesis, that's your probability. Next parenthesis is the complement of your probability. And also for the first exponent is the same as your x value, and then the second parenthesis, second exponent is just these two subtracted. And then you can either put this whole thing into your calculator, or you can go to Binomial PDF and plug in everything. Then we can, the next problem, what is the probability that Miss Carter makes at least 65 shots? So the key word here is at least. And so if it's at least, you do everything the same thing, but you have to add on more until you get to 80. Because at least means everything greater than 65. Or 65 and greater. So what you want to do is you want to put this all in Binomial CDF in your calculator. And then once you get that number, you have to subtract 1 from it. But the thing is, if you put your number in Binomial CDF, you have to put it x minus 1. So if this was 65, you have to put 64 in your calculator for that. So once you find that number, you subtract 1 from it. So once I put this in the calculator, I got 0.9839. I have to subtract that from 1 since it says at least, and you get this number, which is your answer. But if it's at most, it's basically the same thing, but easier. You still go to Binomial CDF, but you just put in x. You don't have to do x minus 1, so you put in 65 as your thing, and you don't have to subtract from 1. So basically, put everything in your calculator, and you're good to go. And then mean and standard deviation. So mean is equal to n times p. Our n in this case is 80, and our p is 70. This came from the problem. And so all you have to do is multiply that to get our mean, which is 56. And then standard deviation, we use this formula, plug everything in, and we get 4.1. 6, normal approximation to binomial distribution. So we learned in class, the more sample sizes, the more n you have, that makes the distribution more approximately normal. So the more curve, like the bell-shaped in the middle, where 68% of the data is within that, is within 1 z-score. And again, the formula for z-score is x minus mean over standard deviation. And so this is what we did back in like chapter 1 and 2. We used the normal CDF and we plug in everything to find the answer. But the thing that we learned new was about large count condition. This is when like you don't know if your independent events are like good enough, or like your sample is big enough. So the way to do that is if you do n times p, you have to make sure that's greater than 10. We also have to make sure that n times 1 minus p is also greater than 10. You have to make sure those 2 requirements are met. Geometric probability, the 4 conditions of geometric distribution, they're all the same except for one of them. And the thing that's different is that there is not a set fixed number of trials. Instead, this is called the variable of interest. So the formula is this. You really don't have to use this, or you just have to use a calculator, you know. Mean is 1 over p, and the standard deviation is greater than 1 minus p over p. Example, so what is the probability that you pick an ace on exactly your 5th try? Probability that you pick an ace is 4 out of 52. So what is it that you get on your 5th try exactly? So that means the first 4 tries you didn't get it. So you have to use the complement of that, which is 48 out of 52. So you do 48 out of 52 to the 4th power, and then times 4 out of 52. Because altogether, there's like an imaginary 1 right here. So altogether, that gives you 5. And so the first 4 were fails, and the 5th one was your success. So that's how you do this. And yeah, so this was just like an overview of what the test is going to be on. If you're still not comfortable and confident about it, go over the Schoology slides and also do your yellow packet. But yeah, That's it. See ya.